how to memorize trigonometry identities. We write down the trigonometry function in the following way. So I have sine, cosine, I write down 1 on here, write down tangent here, cotangent here, and secant here, cosecant here. From this diagram, I have the following properties. The first property is co-function formulas. Co-function formulas, the horizontal line for the horizontal line, we have sine theta equal cosine 90 degrees minus theta. Tangent theta equal cotangent 90 degrees minus theta, and secant theta equal cosecant theta 90 degrees minus theta. For example, since 30 degrees plus 6 degrees equal 90 degrees, therefore I have sine 30 degrees equal cosine 60 degrees. And tangent, since 10 degrees plus 80 degrees equal 90 degrees, therefore tangent 10 degrees equal cotangent 80 degrees. Since 20 degrees plus 70 degrees equal 19 degrees. Therefore, secant 20 degrees equal cosecant 70 degrees. So 30 plus 60 is 90 degrees. So sine 30, cosine 60. And 10 plus 80 degrees, 19 degrees. So tangent 10 equal cotangent 80 degrees. This formula. 20 plus 70 equal 90 degrees. So secant 20 degrees equal cosecant 70 degrees. For special angle, special angles, we have 30 degree, 45 degree, 60 degree. For these special angles, we have the following table. Here's theta. The angle here is 30 degree, (45 degree), 60 degree. Now, sine theta. For 30 degrees, we write down the formula as this. Bottom 2 on top square root 1, 2 square root 2, 2 square root 3. So 30, 45, 60. So square root 1 over 2, square root 2 over 2, square root 3 over 2. So 1, 2, 3. For cosine, cosine 30 degrees equal 30 degrees plus 6 degrees is 19 degrees. So cosine 30 degrees equal to sine 60 degrees. Therefore, this one equal, and sine 60 degrees equal 2, 3. And cosine 45 equal, because 45 degrees plus 45 degrees equal 90 degrees, so cosine 45 equal to sine 45. So therefore, this angle equal 2 square root 2. It's here. Sine 45 equal to cosine 45 equals square root 2 divided by 2. Now, cosine 60 degrees equal sine 30 degrees, because 60 degrees plus 30 degrees is 90 degrees. Therefore, equal 2, 1 equal 2, 1. So sine 30 degrees here. We can memorize reciprocal identities by the same diagram. Reciprocal identities by the same diagram. So we write down sine theta, cosine theta, 1 tangent theta, cotangent theta, secant theta, cosecant theta. For the same diagram, we have reciprocal identities. For example, any line, any diagonal line, we have, for example, this line. For example, this line, we have tangent theta times cotangent theta equal to 1. Or we can write down tangent theta equal 1 divided by cotangent theta. So tangent theta equal to 1 divided by cotangent theta. For this diagonal line, we have we have sine theta cosecant theta equal to 1, or we have sine theta equal 1 over cosecant theta. For this diagonal line, we have cosine theta times secant theta equal to 1. Therefore, or we can write down cosine theta equal 1 divided by secant theta. So this diagonal line, we have this trigonometry, this function times this function equal to 1, this function times this function equal 1 along this line, and this function times this function equal 1. Neighboring property. Neighboring properties, we have the following neighboring properties. We write on the same diagram as sine theta, cosine theta, tangent theta, cotangent theta, secant theta, cosecant theta, for sine theta equal tangent theta times cosine theta. So this function equal this one times this one. So two neighbor functions we time together, we get this one. For example, this one we have here, this. I write down here. So sine theta equal tangent theta times cosine theta, and cosine theta equal this function times this function equal to sine theta times cotangent theta. And this function tangent theta equal this function times this function. So tangent theta equals sine theta times secant theta. And secant theta equal tangent theta times cosecant theta. Cosecant theta equal secant theta times cotangent theta. Secant theta times cotangent theta. And cotangent theta equal cosine theta times cosecant theta. So any function equal to product of neighbor functions. Pythagorean identities. We use the same diagram, this. So sine theta cosine theta 1, tangent theta cotangent theta secant theta, cosecant theta. From this diagram, we write down the following again. Here's 1. So on top triangle, inverted triangle, we have sine theta cosine theta. That's 1. And we have here tangent theta secant theta cotangent theta cosecant theta. the square, the top square, then sum equal to bottom square. For example, this inverse triangle, we have this formula. For the top, this triangle, we have the sum of the square on top equal to bottom square. So this one we have sine theta square plus cosine theta square equal to 1 bottom 1 square equal to 1 square equal to 1. And this triangle, this inverse triangle, we have tangent theta square plus 1 square equal the bottom square equal to secant square. And this triangle, we have 1 square plus cotangent square equal the bottom cosecant square. So 1 square is 1. 1 square is 1. So this square plus this square is bottom square. And this square plus this square equals bottom square. This square plus this square is bottom square. For example, I give example. The derivative d tangent theta d theta equal tangent theta square plus 1 so this square plus this square equal to bottom secant theta square. Secant theta square and secant and cosine theta, they are inverse, so equal 1 over cosine theta square. And on this side, d cotangent theta d theta equal minus 1 plus cotangent theta square equal 1 plus cotangent square equal cosecant square, so equal to minus cosecant square. And then this cosecant and secant, they are mutual inverse, so I have here is minus 1 over sine theta square. I can prove one of identity. For example, I can prove tangent theta square plus 1 equal secant theta square. So solutions here. Left hand side equal tangent equal sine theta divided by cosine theta square plus 1 equal sine theta square cosine theta square plus 1 and equal sine theta square cosine theta square plus 1 I can convert to as cosine theta square cosine theta square. So cosine theta square divided by cosine theta square is 1. So 1 come here. So now I have the common denominator. So equal. So cosine theta square. On top, sine theta square plus cosine theta square. And sine theta square plus cosine theta square equal 1. So sine theta square plus cosine theta square is 1. Therefore, I can place here, I can substitute 1 cosine theta square. So 1 over cosine theta square and equal and cosine theta square from this property cosine theta equal to 1 over secant theta. Therefore secant theta square. Sum to product formulas. We use this diagram to memorize. We write down S plus S and 2SC and S minus S 2CS. Now C plus C, and here we have C minus C bracket and minus sign in front. And we organize this way. See, what's the physical meaning? The meanings here. The horizontal line indicates sine plus sine equal 2 sine co, and sine minus sine equal 2 cosine. Now, this we go this way, diagonally. From this diagram, we have the following 4 equations. Sine plus sine and equal to sine co and sine minus sine to cosine. And co plus co plus co equal to 2 co. And minus here we have to pay special attention. Co minus co equal 2 sine. So sine plus sine, 2 sine co. So we write down here as alpha, beta, and here we write down alpha plus beta divided by 2, alpha minus beta divided by 2. So sine minus sine, 2 cosine. So sine minus sine, 2 cosine, 2 co. Two cosines, alpha plus beta divided by 2, alpha minus beta divided by 2. And co plus co, 2 co plus co, 2 co, alpha plus beta, alpha minus beta divided by 2. And minus co, 2 sine, minus alpha beta. Cosine alpha minus cosine beta equal 2 times alpha plus beta divided by 2 alpha minus beta divided by 2. So all these columns are alpha plus beta divided by 2, alpha plus beta divided by 2, alpha plus beta divided by 2, alpha plus beta divided by 2. All these columns alpha minus beta divided by 2, alpha minus beta divided by 2, alpha minus beta divided by 2, alpha minus beta divided by 2. So I can verify this equation. I call equation 1. This equation 2, this equation 3, this equation 4. I can verify equation 1. I copy equation 1 here. Equation 1 is sine alpha plus sine beta equal 2 times sine alpha plus beta divided by 2 cosine alpha minus beta divided by 2. We can verify this is correct by setting beta equals 0. So if beta equals 0, then sine beta equal sine 0 equal to 0. Now this equation will become sine alpha, so this term is 0, to equal 2 times sine beta 0. I have only alpha divided by 2, so alpha divided by 2 times cosine beta 0. So here I have cosine alpha divided by 2. And this equation is the same equation as sine double angle, because we remember that sine 2 theta equal 2 times sine theta cosine theta. So if you remember this formula, so this sine 2 theta equal 2 times sine theta cosine theta. This angle is double this angle and double this angle. This argument of sine is double this angle, and our formula here, this angle is double this angle and this angle. Therefore, this equation is the same equation as this one, and Therefore, our equation 1 is consistent with this equation. So let's double. Double. Product to sum formulas. We can use the same diagram to memorize product to sum formulas. So we have here S plus S 2 S C S minus S 2 C S co plus co. Here is minus co minus co. So horizontal diagonal this. So to convert product to sum, we had following. Two sine co, 2 sine co equal sine plus sine. Sine plus sine. Now 2 cosine equal to sine minus sine. Minus sine. Two co equal to co plus co. 2 co equal co plus co. Co plus co. And here is 2 sine sine, 2 sine sine equal minus co minus co. So on the left side, I write down alpha beta, alpha, beta, alpha, beta, alpha, beta. So on the left is products. So sine times cosine. So it's product cosine times sine, cosine times cosine, sine times sine. So on the right side is sum. So I can write down alpha plus beta, alpha minus beta, alpha plus beta, alpha minus beta, alpha plus beta, alpha minus beta. So alpha plus beta, alpha minus beta. So this is equation 1, equation 2, equation 3, equation 4. We can verify equation 1 is correct. Verify equation 1. Equation 1, I copy equation 1 as follows. 2 sine alpha cosine beta and equal sine alpha plus beta plus sine alpha minus beta. If beta equal to alpha, beta equal to alpha, then on the left side I have 2 times sine alpha cosine beta equal to alpha, as this also is to alpha. So here sine beta equal to alpha, this is 2 alpha. And beta equal to alpha, this is 0. So it's 0, so plus 0. Therefore, we get double angle of sine. So sine 2 alpha equal 2 times sine alpha cosine alpha. And this equation is correct. This equation correct. Therefore, this equation is consistent with this equation. Sum of 2 angles and cosine of sine. So sum, so alpha plus beta, let's sum, or difference minus difference, take sine, and alpha plus minus beta, take cosine. In this case, I do not have a diagram, but I use, I remember this way. So sine and cosine. So I write down sine cosine, same sign, and cosine, different sign. What that means? So sine cosine, same sign. Sine, sine, cosine, same sign. If this plus, I get plus. If this minus, I use minus. Now cosine, so I use cosine, different sign. Cosine, cosine, different sign. Different sign means if this plus, I get a minus. If this minus, I get a plus. So here's alpha, beta, and alpha, beta. Alpha, beta. So sine, cosine, same sign. Cosine, different sign. For this problem, we can have this formula. We have following example. So example. What is sine 15 degree? So solution is this. If don't use calculator, so solution for this problem is sine 15 degrees equal sine 45 degrees minus 30 degrees. Now equal sine, cosine, same sign. So sine sine, cosine, same sign. Same sign means if here's a minus, I here minus 2. So 45, 30. 45, 30. So sine 45, we have here sine 45 is this one. We have special angles, this table. So I have here is sine 45, cosine 30 degrees. So cosine 30 degrees here. Minus cosine 45 equals sine 45. Sine 30 equal 1/2. So this one equal 4, 6 minus 4, 2. So this one equal this. This is the answer. Now, another example. What is cosine 75? Cosine 75, we can write down as follows. Cosine 75 equal cosine 45 plus 30 degrees. So equal cosine sine, different sign. So I have a sine, sine, different sign. Different sign means if this plus, I have here's minus. So 45 degrees, 30 degrees, 45 degrees, 30 degrees. So cosine 45 equals sine 45. Cosine 30 degrees, sine 60 degrees. Minus, here we have the same thing. I just copy down here. Now, I use special angles values. So sine 45 equal sine 60 degrees minus sine 45 equal sine 30 degrees 1. So this one equal 2 to square root 6 minus 4 square root 2. So this one equal 4 square root 6 minus square root 2. And actually, this results is equal to here. And by co-function property, so therefore we verified sine 15 degrees equal cosine 75 degrees, because 15 degrees plus 75 degrees equal 90 degrees. So sine 15 is cosine 75. Double angle formula. Double angle formulas. I write on this form 1 plus co 1 plus co equal 2 co half square. This one formula and another formulas I memorize in this way. 1 minus co 2 times sine half square. So 1 plus cos, 2 cos half square, 1 minus cos is 2 sine half square. Example, we would like to perform an integral. Minus 8, 1 minus cosine x dx. Solution. The constant, I can take it out. One divided by 1 minus cosine x dx. Minus 8. 1 minus cosine x is here. One divided by 2 times sine half x square dx. We notice that this is x, this x divided by 2. So we put these 2 into here. Minus 8 sine square x divided by 2. 2 I move to here. Now, this 2 x divided by 2 and x divided by 2, I can change the variable. I define x divided by 2 as a new variable u. Now, this original integral will be like this. Minus 8 integral 1 over sine u du. And remember, 1 over sine so 1 over sine equal cosecant, because sine and cosecant, they are inverse to each other. So I have here is minus 8 cosecant u square du. And as we did before, d cotangent d theta equal minus cosecant square Therefore, the integral cosecant square equal minus cotangent. So this is minus 8. This one equal times minus cotangent u and plus an integral constant. And minus plus, so 8 cotangent u plus minus 8 times constant is a new constant. I write a constant prime. And u is defined as x divided by 2, so we can write down as 8 cotangent x divided by 2 plus constant. And if you want, you can express the results as 8 1 over tangent x divided by 2 plus constant. So both results is good.